Excuse me. Greetings, Saintsmen. We have lesson 11.2, which is the area of circles and sectors. Remembering what a sector is, reviewing from the last lesson. So when you have a circle, and again, you guys are going to want your compass handy for this lesson. Of course, that point is the center of the circle. It's how we name the circle. If we create a central angle here, is effectively this pi piece, what's referred to as a sector. Now, for that entire circle, we can have an area within it, and then of course we can subdivide that proportionally as to how much is being taken up, how much space is being taken up by just that sector alone, proportionally within the degrees of the circle versus the arc length or central angle. We're going to take this area, which is going to be equal to pi times the radius squared. This is your formula for the area of a circle, right? Area of a circle is pi r squared. I've always laughed about this to this day. Had a middle school student, again, this would be about 15 years ago, who used to always joke. And she thought it was the funniest thing, and I thought it was kind of a lame joke, but I remember it to this day, giggling that the idea that pies are square, except for that they're round. It's a terrible joke. Yeah, pi r squared is the area of a circle. So yeah, pies are square if you need some way to help you remember that formula. So except for the hair round, we're going to find the area of a circle. This is our first example with a radius of 8.5 inches. Okay, so first example for today. Again, employing our formula, a is equal to pi times the radius squared, and then we're just going to substitute here. Okay, pi times 8.5 squared, okay, which 8.5 squared, when you punch that into your calculator, is going to give you 72.25. And again, we're going to leave this in terms of pi, and these are going to be square inches, okay? I'd also like for you guys to give an approximation in addition, which is about 227 inches squared, but the key is that you give me the answer in terms of pi, which is the most exact answer that you can give me. Let's do another example, because these are pretty straightforward after we did lesson 11.1. We're going to find the diameter of a circle with an area of 153.94 feet. Okay? Find the diameters, find the diameter. So let's go ahead and revise that. Again, our area is pi r squared. But then they give me area, right? So then this is the A I can replace with 153.94, right? And that's equal to pi times the radius squared. And we're going to solve for r here. So in order to get r by itself, the first thing we have to do is divide both sides by pi, right? To get rid of that pi. So now r is almost by itself. We have 153.94 over pi is equal to r squared. How do we get rid of the square? But we're going to take a square root of both sides. And this is your solution. It's the square root of 153.94 divided by pi. Pi being on the bottom there is equal to r. Now you can punch that into your calculator. Ooh, goodness gracious, gentlemen, hold on real quick. It's saying that we have to find the diameter, right? Remember that diameter is just going to be 2 times the radius. So it's going to be 2 on the outside. Big square root 153.94 over pi. And that's feet, linear feet. That is your exact answer, okay? Punch that into a calculator. It's about equal to 14. Okay, so right now I want you to practice on your calculator and make sure that you understand how to do the keystrokes to get this. And some of you will not, and you're coming to class and you're going to ask me how to do it, and I'll probably just say to, I don't know, go figure it out. You should know how to use your calculator by now. So it's time for you to practice. And you get it wrong on your test, then you just got it wrong on your test. It just means that you didn't do the proper practice when you were supposed to. It's not time just to figure out your calculator when it's, test time. We're going to find areas on the next example. Sorry, not areas, the area of the sector formed by angle PSQ. So, let me go ahead and draw this diagram for you guys. Ready? So we have a circle. Center is a circle S. We have P, S, Q. Right. Also going to put on here R so that we can form this major arc, right? This is a 135 degree central angle, and the circle has a radius of 15 centimeters. Okay. So, how are we going to do this? Well, here's our sector right here. All right. So it is that proportion is the 135 degrees of the 360 is going to be that portion of the circle that we have. But then we also need the area of the whole circle, right? So this is just the fraction of the circle that we're looking at, right? That gives us the sector. The whole thing is going to be pi times the radius, which is 15 squared, okay? So we simplify 135 over 360. You can divide both by 45. So you're going to wind up getting 135 divided by 45 is 3, and 360 divided by 45 is 8. So 3/8 times, and then pi times 15 squared is 225 pi. So we have a little bit more work to do. We're going to multiply that on, right, this is all over 1, so multiply that times the top. So we're going to get 675 pi over 8 centimeters squared, and that is your answer. This is about equal to, you're going to punch it into your calculator, 675 times pi, and then you divide by 8. You should get about 265.07 centimeters squared. So just understanding how to get that approximated answer in addition to the exact answer. Okay, so look at that same diagram here. Let's work that backwards, right? So we have S again, and we have P, S, Q. And we have the 135 degree central angle, okay? We have R for the major arc. And all we're going to be given is the area of the sector. Now, hypothetically, this is the only thing that's changed. And in this case, we have 48 feet squared. And what we're going to find is the area of circle S. Well, how do we do that? Well, we're going to take the area. So the area of the entire circle is 48, and that's going to be equal to the fractional area, or the fractional sector, right, 135. So the area of the whole circle isn't, the area of the sector is 48, right? So it's 135 over 360, and then times the area of the entire circle, right? Right, so that's the sector area is equal to the fractional degrees, right? 135 over 360 in this case, of the sector times the whole circle. And we're just going to go from there. To get the area of the circle, right, we're just going to do this. Should be pretty straightforward. These guys are all going to factor out, okay? Then I have to multiply by 360 over 135 on both sides. And then, really it's like 8/3, right? Or 3/8. Wasn't that what this was? It's 3/8. So 48 times 8 divided by 3. Which, according to my calculator, is 128 feet squared. And that's it. Last example we have for this lesson is a composite area problem. And I love these problems. In so much you guys are going to kind of crack up as I talk about how much I love this and what we're going to actually have here. These are semicircles, okay? And I have here a square. With a side length of 8 meters, and I need to find the area. This is the whole thing I'm given my diagram. Oops, that was weird. Okay, so composite area. Here's how it works. Composite area is I effectively have 3 subfigures right here. I have a, looks like a heart, correct? So then how do we actually do this? Well, we have right here we have a square, right? So we have to find the area of a square, which is really just the side times the side. And then here I have a semicircle and I have a semicircle. Remember how we find that the area of a circle is pi r squared, so a semicircle is half of that. So half of pi r squared, and the area of half of area is equal to 1/2 pi r squared. Okay? So we're going to get the area of our total figure is going to be the composite area of the three figures that I've subdivided this into. So it's the area of the square plus this is a sub 1 and this is a sub 2. Right? I could call it semicircle 1 and semicircle 2, but just, whatever. It's just faster to call the whole figure. This is figure the first. Figure 1. And here's how we're going to do it. Think about how you found the area of a square, right? Side squared, so 8 squared plus. In this case, it's going to be 1/2 of pi r squared plus 1/2 of pi r squared, which you guys should know is going to be 8 squared plus what's 1/2 pi r squared plus 1/2 pi r squared is just pi times radius squared, right? 1/2 plus 1/2 is 1 whole. And then what's my radius? But let's go back here. If this guy is 8, right, the radius of this thing would be just half of that, which is going to be 4 meters, right? So it's going to be pi times 4 squared. So 8 squared is 64 plus 4 squared is 16 pi. And then what units were those? Meters? Meters squared. Gentlemen, you leave your answer like that because you can't combine. Like you couldn't combine 64 plus 16x, so you can't do that either with pi. For the record, when you punch that into a calculator, it should give you about 114.2 meters squared. Okay? Good luck. This is 11-2, and you will get a chance to do this all in class. Thank you.